The theory of plate tectonics. The Earth is a very dynamic planet. And here's a picture of the continents, and if you look, you can see arrows are showing what direction the continents are moving. Scientists have shown that the land masses are not fixed, but slowly migrate across the globe. And so here you can see a picture of the splitting of continental blocks, resulting in the formation of new oceans. So here's Egypt, there's Saudi Arabia, the Sinai Peninsula. Here's the Red Sea, and you can see that Saudi Arabia and Egypt are getting farther away from one another and making the Red Sea larger. And then there are other places where older seafloor is recycled back into the Earth's interior. And all of this moving around will generate earthquakes, which can cause damage to buildings, as you can see. Can create volcanic eruptions. This is a picture of Mount Pinatubo erupting in '91. And you see a giant ash cloud coming up out of that particular volcano. And it will also result in mountain formation. The scientific theory which describes the mobile Earth is called plate tectonics. Because the theory of plate tectonics was the outgrowth of an earlier idea known as Continental Drift is a good place to start first. A revolution in the earth sciences began in the early part of the 20th century as a then radical proposal that the continents drifted about the face of the Earth. The origin of this revolutionary hypothesis, known as Continental Drift, is credited to Alfred Wegener, a German meteorologist and a geophysicist. And he proposed that a supercontinent, which he referred to as Pangaea, existed over 200 million years ago. And so in the picture, you'll see Pangaea is breaking up into smaller land masses, and then over time, they have continued to drift farther apart to present day. Wegener and others who advocated this idea collected substantial evidence to support the idea that Pangaea did exist. And here is some of that evidence. One is the fit of the continents. So if you look, the east coastline of South America and the west coastline of Africa look like they could fit together. I'm sure when you were in elementary school, first grade, kindergarten, whenever the first time was that you looked at a map, you noticed how the shape of the coastlines looked like they could go back together. And just like that, Wegener first suspected that the continents might have been joined when he noticed the similarities between the two coastlines. And so he proceeded to make a crude jigsaw puzzle fit of all the continents and said, maybe they could have all fit back together. He also gathered fossil evidence. So we're going to watch the continents drift apart to present day. Fossils of the same ancient plants and animals are found today on widely separated continents, including South America, Africa, India, Australia, and Antarctica. So this fella was a reptile that existed around 240 million years ago, and you can see that his fossils were found in South America and Africa, and so they use this little symbol of footprints to represent where they found the fossils of this creature. The Mesosaurus fossils, a reptile that swam in, or I should say the Mesosaurus, a reptile that swam in freshwater lakes and rivers. Fossils have been found in South America and in Africa. And you can see that they use little splashes of water to represent where they found the fossilized remains of this reptile. And last but not least, in terms of the reptiles, the Lystrosaurus, a reptile that roamed the land, and they found its fossils in Africa, in India, and in Antarctica. Antarctica is a pretty weird place to be finding reptile fossils. I'm sure that probably that thought has entered into your head. And also, for good measure, we have a plant called Glycopterus, and Glycopterus fossils were found in Africa, India, Australia, India, Africa, South America, and Antarctica. And again, Antarctica is not what you think of when you're thinking about plants. So obviously something had to be different about Antarctica at one time or another. And you can see that they use little leaves to represent where they found the fossils. And so the question is, how do land animals migrate across wide expanses of open ocean? Well, according to Alfred Wegener, they didn't have to. That when the continents were connected, the animals would have been able to roam freely from one place to another. Now, there's also evidence from rocks. So on here it says, when working with a jigsaw puzzle, everyone knows that in addition to the pieces fitting together, the picture must be continuous as well. The picture that must be matched in the Continental Drift puzzle is represented by the rock types and mountain belts. And so here we have a picture of our continents, and it says the Appalachian Mountains trend northeastward along the eastern flank of North America, and then they disappear off the coast of Newfoundland there. Now, if you go over across the ocean, mountains of the same age and structure are found in the British Isles and Scandinavia there. When these land masses are placed in their pre-drift locations, these ancient mountain chains form a nearly continuous mountain belt. And so the theory is that perhaps this mountain range formed during the collision of the creation of Pangaea. But we have a picture here that matches. So it's not just the shapes fit, but the picture on the different shapes match. And so we say here, okay, this is good and all, but still that's not enough evidence all by itself. So we also have some climate evidence.